Hi, I'm Lauren.
And I'm Nick.
And welcome to GTCN's kickoff episode of Ramblin' Research, where we highlight Georgia Tech's most interesting research projects happening right here on campus.
That's right, Lauren. There is so much innovative and amazing research happening all over campus that affects our lives in both subtle and obvious ways.
Our goal here at GTCN is to highlight what makes Georgia Tech a #1 research institute in the country. Today we have Shelby out in the field covering a story that affects all of us in these difficult economic times.
Take it away, Shelby.
Hi, I'm sitting here with Robert Engler, and he's here to tell us about fuel efficiency in trucks and his research assignment. Thank you for meeting with us.
My pleasure. Just for your viewers, we're out at Georgia Tech Research Institute, the Cobb County Research Facility,
Yes.
which is about 25 minutes north of the main campus. Our headquarters of GTRI, of course, is on the campus. And we're in the Aerospace, Transportation, and Advanced Systems Laboratory.
Explain that you guys are an applied research agency. Can you explain to me a little bit what that means?
I sure can. GTRI, being the research institute, does a little bit different than what you'd find on campus in the academic departments, and that is we're the applied research arm of Georgia Tech. So we take what you folks on campus develop in terms of high technology, engineering and so forth, and then get to the task of applying that to real-world applications. In this case, it's improving the drag and reducing the drag and improving the fuel efficiency on tractor trailers. But essentially, it's applying techniques and technologies that we learn about and that you folks on the AE school, the Aerospace Engineering School, and the Mechanical Engineering School, for instance, and some others, are quite experts in, and we're now applying that technology and that knowledge to the real world.
From looking on the website, the project seems like it's mostly about, big trucks. What other things are you working on for fuel efficiency?
The technology that's applied to trucks actually is aircraft technology. I've been developing that for many years, since when I worked for the Navy, and actually applied it to real-world aircraft carrier-based jet aircraft. It's aerodynamic technology, which in that case was intended to provide high lift and make very short takeoff and landing distances. We have also found that the same technology can be used to reduce drag on aircraft. So if it can do that on aircraft, is there any usefulness to it on ground vehicles? And these days, with fuel economy being so important and the cost of fuel being so high, if we can reduce the aerodynamic drag, we can do a lot to make ground vehicles more fuel efficient. And tractor trailers, if you look at them, are probably one of the worst in terms of fuel efficiency, because they're really just rolling boxes on wheels. The manufacturers have built reasonably good front ends. The tractors are getting to be pretty aerodynamic, but the trailers are almost always rectangular boxes, which are not very good drag-wise, and therefore the whole vehicle is not very good fuel economy-wise.
Explain, I guess in reference to a new hybrid Honda, how much gas a truck like this, like one of these, would use?
Okay. Typically, a good hybrid car might get 30, 35. I've even heard ads for 40 miles to the gallon. That is partly because they're small and streamlined, but it's partly because of the hybrid battery and gasoline technology that they employ. Tractor trailers, because of their huge size, and also because of their weight, many of them maximum weight is 80,000 pounds, but also because they're big boxes on wheels, typically might get 5 to 6 miles per gallon.
Wow.
So that isn't very good compared to 35 to 40.
That's a big difference.
Yeah. Here's where we started.
Okay.
This is a streamlined car that we built specifically to look at drag reduction. Remember this technology, we use blowing to do this high lift development, and we want to use blowing also to do drag reduction. So the question was, since we hadn't done this before on vehicles, could we generate a small-scale model for the wind tunnel? And so we're taking on a challenge of taking what's already a good vehicle and trying to make it better. If we can improve the drag on this, then we should be able to do wonders on tractor trailers. And we found that we could indeed reduce the drag on a very generic one of these by 84%. That's a
Oh,
huge,
wow.
a huge reduction. If you look at that and plot the drag on the tractor trailer, we actually reduced the drag coefficient of a tractor trailer to half of a hybrid battery powered car. That's half of a
Wow.
production car. And that's comparing a car to a tractor trailer. And the coefficients let us look at those comparisons directly.
So you're talking a truck like this getting 20 miles?
Could not necessarily. It's the drag coefficient that we're reducing. So we look at the drag comparison directly.
Okay.
Yeah, and we'll talk to you in a minute about how many miles per gallon we got. But
Okay.
but what you need to look at really is percentage increases relative to a stock truck. Normally a tractor trailer has just a square cornered back end like
Correct.
that, and that's where all the drag comes from because that's a very poor aerodynamic shape.
Okay.
So we've put curved surfaces on the back and blowing slots around all four corners, and we hook that up to a compressor of some type. It could be off of the diesel engine using the supercharger, or wherever you can get a compressed source of air. And you can see that the air, when it comes out of these slots, turns over these round corners, and when it does that, it dramatically reduces the drag on the back of that truck. There's a number of aerodynamic reasons for that happening, but just take my word for it that it dramatically reduces the drag. But just to make it relative, if all the tractor trailers in the United States applied this technique and gained 12% fuel economy increase, that's 2.4 billion gallons of diesel saved every year.
That's a lot.
Yeah, 2 years ago when we were at the high price, the diesel fuel was on the order of $5 a gallon to these guys. So we're talking 12, 14 billion dollars of fuel costs saved if everybody in the U.S. used that on their tractor trailer trucks. So that's the relative importance of this technology to saving fuel in the United States for tractor trailers.
So you mentioned sponsors. And
Right.
with sponsors, that means money.
Right.
Money, jobs
Okay.
for students. Tell us
Absolutely. Let's talk about students. This facility, because we do lots of wind tunnel work, lots of acoustic testing, and and you have only seen one lab. There are several
Right.
labs, several divisions out here. We employ a large amount of co-op students. I've always used co-op students to run the wind tunnel. We actually had co-op students built part of the back. We were having them doing things like riveting, putting parts on and so forth. Then when we went to the test in Ohio, we took co-op students with us to be part of our test team. So these are undergraduate students who are now going off-site to a real test facility to test full-scale, in this case, road
Correct.
vehicles.
Okay.
So students get to do that here. We also have postgrads and postdoc students that do things a little more advanced than this, but they get the chance to do that out here. So again, we're applied research facility where we're doing all kind of, let's call it leading edge advanced technology and applying that to real world facilities.
So research is being done in Marietta to help us transform the way we do transportation. I'm Shelby Bernard, and this is Robert Engel, and thank you for tuning in to Ramblin' Research.